So I'm sorry I couldn't be with you today, but this is what you should be doing today. I want to make sure you guys understand it, understand what the activity holds and everything. Okay, so it's called Graphing Periodic Trends Activity. It says use the information below in the tables to complete the graph as described below. So basically here we have just a set of elements, different elements, obviously not all the elements in the periodic table. And then they have three different trends that we're going to look at. We're going to look at how the atomic radius differentiates among these. We're going to look at how the ionization energy differentiates and how the electronegativity differentiates. This is for the people that are online. So if you have colored pencils or pen, or it doesn't really matter. Hopefully you do have colored pencils. I do have some. However, I don't know if they were moved. So, or if you just want to use highlighters, that's fine too. It says using colored pencils or pen, list under the symbol in this order: the atomic radius, the first ionization energy, and electronegativity. Use different color for each property. Example, write all the atomic radius values in red, all the first ionization energies in green, and all of the electronegativities in blue. Again, this is just an example. Let's say you have a blue, black, and then you have a pencil. That's perfect. So atomic radius can be a blue pen. Ionization energy can be a red, black pen, and then electronegativities can be in pencil. And then it says observe the trends in each property as you go down the alkaline metal group as you go across period 3. Write each statement written as the opposite sides, completing each statement with observed trend, increase or decrease. Okay, so what are you supposed to do? So you see where it says hydrogen here, H. Okay, so we have H right here. So the first thing is we're going to write atomic radius. We're going to write 31. We're not going to write the, so what I would do if I were you, and this, again, you can do it in Cami, or you guys, since you guys are at school, technically you can print this. If you cannot print this, just do it in Cami, okay? I know you guys have access to Cami. Okay, so for me, it's like I just press on text, and then I get this little text box down here, and then I'm going to put 31 for atomic radius. So atomic radius can be, for me, can be black. Oops. Okay, so I'll put 31 there. And then also I will make a note here that all the atomic radiuses will be in black. Okay. All right, and then I will write the ionization energy also of hydrogen, which is 1,312. So I'll press my text box again. And then, yeah, basically you go through each one of these like so. And now I don't want it black, and I can change the color, I believe. Yes, right here. So I want it red. And then this one will be the, oops. Okay. Sorry about that. It's a little tricky, 1,312. Okay. And then I'll put, I'll insert another text box there, and I'll put red, so that way I know ionization energy is in red. And again, you can do this in Cami, you can print it out. And then electronegativity is 2.1. I'll press my text box again, and that's again for hydrogen. Okay, 2.1. Oh, sorry. I wanted another color. I don't want it red. Maybe I can do it, maybe blue. Oh. Why does it color? Okay. Sorry, I don't like that blue. It's too similar to black. Well, that's red again. Oh, this blue. There we go. Okay, and then I can insert another text box again to say all electronegativities will be in blue. Okay, so basically you're going to do this for each one. All right, so you're going to do all, if you want to do all the atomic radiuses black, so then you go with lithium. So you're just going to put the values of each one. So lithium would be black. For lithium we would have atomic radius would be 3.128. And again, remember this is black, we said, because that's the atomic radius. And then you can do like all the, if you're doing it online, obviously, it's better just to do them all. That way you're not changing color every time like I did right now. And then you can do sodium 166 for Na. Oops. Oh, an Na is done for you already. Oops, so you don't have to do any of that. But you can write black, or you can write here next to it, you can write atomic radius, whatever you want to do. But as you can see, Na is done for you, so you don't have to do Na. And then you can just move on to K and so on and so forth. So after you finish this, okay, so you're going to graph all these numbers. Basically, you're going to put all these numbers to all the symbols. Okay, then it says across a period. So across is this way. What happens to the atomic radius? So you're going to compare all the first numbers for all of these. Okay, for sodium, magnesium, aluminum, you're going to see how does the atomic radius change. And then it also will ask you across the period, how do ionization energy change? So that's the second number. And then across the period, how does electronegativity change? And what terms do you use? This is number 4, says you use increase or decrease. Please, please, please don't you say up or down, or goes higher or goes lower. You are high schoolers, you are using increase or decrease. Increase again if it goes up, if the values get bigger. Decreases if the values get smaller. Okay, so you're looking at cross. Then as you go down, what happens to the atomic radius? So you're going to compare the first numbers, okay? As you go down the periodic table, does it increase or decrease? As you go down the first ionization, the red ones, do the red ones increase or decrease? As you go down, do the blue ones increase or decrease? Okay, so then you would do that for that as well. Okay, and then once you're done with this. This shouldn't take you too long, but this is all you're doing today. All right, and again, if you have any questions, please email me.